Greetings, Spartan fans. We are going to talk about area of triangles. And as in the last video, nothing is drawn to scale. Calculator for sure, and make sure that you are in degrees. How do you find the area of a triangle? 1/2 base times height. And in order to do that, you need a right angle. Well, not anymore. And perhaps you remember this from other last year, whatever. So you're taught, and I know that you are shocked by the fact I'm labeling the triangle ABC. You've been taught that to find the height, you drop a perpendicular. That's what was always called for me. Drop the perpendicular. Here is side C. Okay, well, to find this height, you would say that the sine of A, alpha, sorry, not, is equal to H over C, sorry. So the sine of this angle is equal to the height over C. Okay, great. Well, solving for H, I get C times the sine of alpha. The base of this big triangle is B. The base of the big triangle is B. Well, area is 1/2 the base, but the height is now C times the sine of alpha. The base is the same as side B. There you go. Area is 1/2 the length of the two sides times the side of the included angle. Alrighty, and then we're also going to add Heron's formula, and I think every teacher says it differently. And if you are interested in the proof, that is begins on page 542. If you're interested in the proof, the area is equal to the square root of S minus A, S minus B, S minus C. What? S is half the perimeter. Half the perimeter. Half the perimeter. Okay. I'm not going to do any what I call plug and chug examples. I'm going to go straight to a word problem. Okay, so if you've got your book, I'm going to look at page 544, number 36. Okay, so we have a circle. Here goes nothing. You know, in Miss Babiak world, that's pretty darn good. So we have a segment of a circle. Radius is 5. Radius is 5 inches. And it's a central angle of 40 degrees. So based on picture from the previous problem, they say segment, but I think they mean right here. Okay, so there's my picture. So first, let's find the area of the sector. Let's find the area of the whole sector, and then we will subtract. I should say we're going to subtract the area of the triangle. Okay, so this is also 5. So the area of the triangle is 1/2 the 2 sides times the sine of the included angle. That's going to be 12.5 times the sine of 40, which is 8.03. So the area of the triangle is 8.03. I get so nervous doing these problems by myself that I make a mistake. Okay, the area of the sector (1/2 r squared theta). This is from, oh my goodness gracious, way back. I don't remember exactly when we covered this, but area of a sector. It's not something you need to memorize. I'll give it to you. I will give this to you. Here's the problem, is that theta needs to be in radians. Theta needs to be in radians. So I'm going to have to go back and redo the sine of 40. That's okay. So this is going to be 1/2. R is 5. And then theta. Ooh, how are we going to convert 40 degrees to radians? That's going to be, oh boy, pi over 180 times 40 degrees. So this is going to be whatever 40 over 180 is. 2/9. So this is 25/2 times 2 pi over 9. Again, I multiplied 40 degrees times pi over 180 to convert it to radians. 1/2 r squared theta came from like chapter 3, I want to say. So don't worry, I'll give that to you if it comes up. I do believe this comes up in one of the homework problems, so you might want to start for yourself. So this is 50 pi over 18. I hope. So this is the sector. Oh, that can be reduced. Sorry, it can be reduced. So I need to go back and find the area of the triangle because I did it in degrees, but I can't do part degrees, part radians. So I'm going to stick to radians. And the reason I'm sticking to radians is because the area of the sector formula only works in radians. So I don't have a choice. I need to use radians for the area of the triangle. So I have to go back to that. So the area of the triangle is 25/2 times 40 degrees. We already figured out was 2 pi over 9. So times the sine of 2 pi over 9. Plugging into my calculator. At this point, you're probably going, Miss Babiak, 2 pi over 9 is the same as 40. I don't know why I'm redoing it. Sorry about that. So this is 8.03, which I already knew. And then 50 pi over 18, which is 25 pi over 9. 25 pi divided by 9, which is 8.72. So when you subtract, you get 0.69 square inches. So I took the area of the sector, 8.72, subtract the area of the triangle, which is 8.03, and you get 0.69 square inches. Make note of the sector for yourself. Let's do one more that involves Heron's formula. That was rough. Sorry about that. All right, we're going to do number 42, which is the area of a lake. So I would stop the video at this point and draw the picture. Here we go. I'm going to start by finding, let me just label these X, Y, Z. Actually, I'll just label them X, Y. Okay, so I'm going to find X. So I can find the area of section A. So section A is equal to 1/2 35 times 80 times the sine of 15. 0.5 times 35 times 80 times the sine of 15. I'm in the wrong mode. I'm in radians from before. Let's try this again. 35 times 40 sine. 362.34. 362.35. If we've got 80 degrees, I'm sorry, if we've got 100 degrees on the outer, then this is 80 degrees. So section B is 1/2 20 times 45 times the sine of 80. So this is 450 sine 80. 443.16. Okay, and we're in feet here, square feet. This is not very focused. Okay, I'm going to find X and I'm going to find Y so that I can use Heron's formula maybe to find the section C. Might be a faster way to do this. I'm going to find side X. So X squared is equal to 35 squared plus 80 squared minus 2 times 35 times 80 times the cosine of 15 degrees. There could very well be a faster way to do this. I'm on my own. This is how I'm doing it. Pause, plug in, get 4707. I can find side Y, then I can use Heron's formula. I could have used Heron's formula for section A, because I know the 35, the 80, the 47.07. So I could have used Heron's formula for section A. If you do that, you should get 362.35. So I need to find Y. And to find Y, right here, so I can use Heron's formula for section C. I could do the, again, side angle side. So I'm going to use law of cosines again to find Y. So Y squared equals 20 squared plus 45 squared minus 2 times 20 times 45 times the cosine of 80. That's going to give me Y, and then I will use Heron's formula to find C. So go ahead and pause. 45.96. So section C, first let's find S. S is half the perimeter, 47.07, 45.96. And this should be plus. I'm glad I just realized that. It should be 1/2 the perimeter, 40 plus 4707 plus 45.96. That would have been not fun. 40 plus 4707 plus 4596 divided by 2. All right, I got S is 66.515. Okay, so the area of section C equal to 66.515. That's S times S minus 40 minus 4707 minus 45.96. Go ahead and plug in. 839.59. So when you add up section A, B, and C, so section A up here, 362.35. B was 443.16. C was 839.59. For a grand total of 443.16. 839.59. 1,645.1. 1,640 ish. And don't forget your units. So I don't doubt that there is probably a faster way to do this. I guess if you would have found the lengths of the sides first, you could have done Heron's formula for all 3 sections. I would rather just do the 1/2 AB sine C for the sections I can. But so there's some word problems having to do with area of a triangle.